A permutation is an arrangement in a definite order of a number of objects taken some or all at a time. If I have to choose R objects out of n object, then R can be less than n or R can be equal to n, because it is nothing but the arrangement of some objects or all objects in the n objects. Sometimes we may get the value as 0 under the factorial, but 0 is not natural number, but we assume 0 factorial to be taken as 1. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am, Vidhyaashram School of Excellence, Mysuru. So here in this session, we'll study about the permutations. So in the last session, we have discussed about the fundamental principle of counting. So the same problems can also be expressed in the form of permutations. Now what do you mean by a permutation? A permutation is an arrangement in a definite order of a number of objects taken some or all at a time. For example, so arrangement of a books in a library. So you always arrange it in a certain form. For example, your mobile password. So if you have used the digits like 9988, you cannot place a password as 8899. You have to use it in a 9988 form. That means in a definite order here. You cannot interchange the order. So the definite order of arrangement of an object is nothing but permutation. So if it is of the one arrangement, then by changing the object, there will be new arrangement. So each and all arrangements of an object, taking some of the object or taking all the objects at a time is nothing but permutation. So when I'm talking about the permutation here, order of the object is very important. So if you change one place of any one object, then we will get a new order. So therefore, for a certain number of objects, there will be n number of permutations or n number of arrangements. What are the observations we'll see in the permutation? Now the number of permutations of n different objects taken are at a time where R is less than or equal to n and the object do not repeat. So I told you, if I have to choose R objects out of n object, then R can be less than n or R can be equal to n, because it is nothing but the arrangement of some objects or all objects in the n objects. So now here, if I want to arrange them, then it will be always in the form of n into n minus 1 into n minus 2 into n minus r plus 1 here. So if r is equal to n here, then the last one will be 1. So if you place r as n, then n minus n cancels, so this will be 1. So it is like n into n minus 1 into n minus 2 into 3 into 2 into 1 towards the last. And it is denoted by NPR. So NPR is nothing but here the number of objects is n and the selected objects is r, and hence NPR can be denoted as n into n minus 1 into n minus 2 into n minus r plus 1. So second thing is the number of permutation of n different objects taken r at a time where repetition of the digit is allowed is n to the power r. So that means if we have to create a 3-digit number out of the numbers 1, 2, 3, 4, 5, where repetition is allowed, then I can use all the 5 numbers in the hundreds place. I can use all the 5 numbers in the tens place as well as units place. So therefore it is 5 into 5 into 5. Now since 3 digits number has to be formed, this is equal to 5 cube. So here I need to choose a 3-digit number where I can use all the 5 digits here. So therefore, there are n 5 digits where 3 digits has to be selected. So therefore it is 5 cube. Factorial notation. Factorial notation is denoted by n factorial and it is represented as the product of first n natural numbers. When I say n factorial, it is the product of a number 1 to n. When I say 3 factorial, it is a product of first 3 natural number. When I say a product of 10 factorial, it is a product of first 10 natural numbers. So that means you need to multiply all the numbers from 1 to 10. So this is known as factorial notation of the product of n natural numbers. Now under this factorial notation, we have the following observation. So 0 factorial. So sometimes we may get the value as 0 under the factorial, but 0 is not natural number, but we assume 0 factorial to be taken as 1. Now again, 1 into 2 is nothing but 2 factorial. 1 into 2 into 3 is nothing but 3 factorial, and it is so on. So therefore, we can write 1 into 2 into 3 into n as n factorial. Also, we can write 3 factorial in the form of 3 into 2 factorial. It's the same. 10 factorial can be written as 10 into 9 factorial, because 9 factorial is nothing but again multiplication of all the numbers from 1 to 9. Then multiplied with 10 will become a 10 factorial. So in general, n factorial can be written as n into n minus 1 factorial, or we can also reduce into n into n minus 1 into n minus 2. For example, this can also be written as 10 into 9 into 8 factorial, which is one and the same. So therefore, we can also reduce this until how many values we want. The next thing is the formula for the permutation. So it is always denoted by NPR is equal to n factorial divided by n minus r factorial. So here, if you take r is equal to n, then the value of NPN will become n factorial, and if you take r value as 0, then the value is equal to 1. That means there will be only one arrangement if no objects are selected. If you select all the object, then the value is equal to n factorial. So if you select 10 objects, where then there will be a 10 factorial arrangements where you can change the order of the objects to get a new arrangement. Next, the number of permutation of n objects where p objects are of the same kind and rest are all or different is equal to n factorial by phi factorial. Now let me take an example of book. So if I change the digits here, for example, K, B, O, O. We can change the letters again, O, B, K, O. We can also change K, O, O, B, O, B, K, O. Like this, just interchanging the alphabets, we will get a new arrangement. But observe here, if you observe this, O and O, O and O, if you interchange them, K, B, if I interchange them, O, O. So we will not get any new arrangement there. So we have the same arrangement. Here also, if you interchange these two, so there is no new arrangement. It's the same arrangement. So when you have a number of letters or a number of objects which is repeated, even though if you interchange them, your arrangement is not changed, then your n factorial is always divided by p factorial, where p represents the same objects. So, or how many times the same object is repeated. In such a case, the permutation is given as n factorial by p factorial. For example, so if I want to calculate the permutation of book, so there are 4 letters out of which I need to choose all the 4. So then 4p4 is equal to 4 factorial. But there are 2 letters which are same. Even though if I interchange them, it is not a new arrangement. It's the same arrangement. So in such a case, I need to divide it by 2 factorial, because how many times the letter is repeated? 2 times. So therefore, it has to be divided by 2 factorial. So this is how we will calculate the factorial or a permutation with repetition of objects. So in the same way, the number of permutations of n objects where p1 objects are of the same kind, p2 are objects of the same kind, and pk are of the kth kind, and the rest, if any are of the different kind, then it will be, the total permutation will be n factorial by p1 factorial, p2 factorial, etc., pk factorial. For example, assume the word mathematics. So count the number of letters here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that means my permutation will be, or total number of ways will be 11 factorial. So I have to rearrange all these letters by interchanging them, then I can create a permutation of 11 factorial. But see here, if I change the place of A with A, it doesn't alter or it doesn't give me any new order. Similarly, if I change M with M, it will not give me any new arrangement. So it's the same arrangement. So then I have to divide this by the letters in terms of factorial and how many times it is repeated. For example, how many times M is repeated? 2 times. So divided by 2 factorial. Similarly, how many times A is repeated? 2 times. So divide by 2 factorial. Similarly, how many times T is repeated? 2 times. So therefore divided by 2 factorial. And the rest of the digits and the rest of the letters is repeated only once. So we have the total number of ways for the permutation of mathematics, or the total number of arrangement of the word mathematics with the repetition of the letters will be 11 factorial by 2 factorial into 2 factorial into 2 factorial. Next, we'll take a few problems on permutation. So evaluate 5 factorial, 8 factorial, 7 factorial minus 5 factorial. So what do you mean by 5 factorial? 5 factorial is the product of first 5 numbers or first 5 natural numbers. That is 2 3s are 6, 6 4s are 24, 24 5s are 120. Next, 8 factorial. So 8 factorial is the product of all the numbers from 1 to 8. So that means 1 into 2 into 3 into 4 into 5 into 6 into 7 into 8. So the answer will be 40,320. Next we have 7 factorial. 7 factorial is 1 into 2 into 3 into 4 into 5 into 6 into 7. So this is 7 factorial minus 5 factorial, 1 into 2 into 3 into 4 into 5. So this is equal to 5040 minus 120. So that is equal to 4920. Next is compute 7 factorial by 5 factorial, 8 factorial divided by 6 factorial into 2 factorial. So 7 factorial is nothing but 1 into 2 into 3 into 4 into 5 into 6 into 7. And 5 factorial is 1 into 2 into 3 into 4 into 5. So we can cancel all the numbers here. So therefore it is 6 7s are 42. So we can also write 7 factorial by 5 factorial in another form. So that is, we can write 7 factorial as 7 into 6 into 5 factorial divided by 5 factorial. So we can cancel this. So 7 6 are 42. Next we have 8 factorial divided by 6 factorial into 2 factorial. So see here, 8 factorial can be written as 8 into 7 into 6 factorial because it's the same. Now we have here 6 factorial into 2 factorial. What is 2 factorial? 1 into 2, it is same. So it is 2. I can cancel 6 factorial in the numerator and denominator. 2 1s are 2 4s are. So 7 4s are 28. So the value is 28. Next one, evaluate n factorial divided by n minus r factorial when n is equal to 5 and r is equal to 2. If you substitute here, n is equal to 5 factorial and r is equal to 2, then it is 5 minus 2 factorial. So 5 factorial divided by 3 factorial, which is nothing but 5 into 4 into 3 factorial divided by 3 factorial. So it gets cancels. So it is 5 4s are 20. So in the smallest form, if you have a form of 5p2, so that means 5p2 is nothing but 5 factorial by 5 minus 2 factorial. So you can just write the first two natural numbers 5 and 4. So that is 5 and 4. So in the same way, if you have any number in the form of 7p3, just write the product of 7, 6 and 5 directly. So 7 into 6 into 5. So that will be the number of arrangement or the shortest method to calculate the number of permutations. Next we have find n if np5 is equal to 42 np3, where n is greater than 4. The value of n must be greater than 4 here. So now np5 can be written as n factorial by n minus 5 factorial. And here we have 42 into n factorial by n minus 3 factorial. I can cancel n factorial on both sides. Then I'll get here n minus 3 factorial divided by n minus 5 factorial is equal to 42. N minus 3 factorial can be written as n minus 3 into n minus 4 into n minus 5 factorial, because 10 factorial can be written as 10 into 9 into 8. That means we'll decrease by 1 here. Each time we'll subtract by 1 here. So when we subtract minus 3 by minus 1, the next term is n minus 4. Similarly, the next term will be n minus 5. So therefore, we can write this as n minus 5 factorial as 10 into 9 into 8 factorial. So denominator here is n minus 5 factorial, which is equal to 42. Now I can cancel n minus factorial here. So we have n minus 3, n minus 4 is equal to 42. So by inspection, we need to find the value of n it is in the form of 42. So 42 can be written as 7 into 6. So here it is n minus 3, n minus 4. So find a number so that when we subtract 3, we'll get 7. When we subtract 4, we'll get 6. So the number is obviously 10. So that means 7 into 6 can be written as 10 minus 3 into 10 minus 4. So observe this, we have n minus 3 into n minus 4 as 10 minus 3 into 10 minus 4. So by inspection, we can directly write n is equal to 10. Or else, we can multiply these two, we'll get a quadratic equation. We can also use the factorization method to find the value of n. Now, the condition was n should be greater than 4, and yes, n is greater than 4. Next question, we have n minus 1 p3 is to n p4 is equal to 1 is to 9. So, we can write this in the fraction form, n minus 1 p3 divided by n p4 is equal to 1 by 9. So, I can write this as 9 into n minus 1 p3 can be written as n minus 1 factorial divided by n minus 1 minus 3 factorial. And here 1 into n p4, which can be written as n factorial divided by n minus 4 factorial. Now here, let me keep 9 as it is, n minus 1 as it is, and here we have n minus 4 factorial, and here n factorial can be written as n into n minus 1 factorial, and here we have n minus 4 factorial. So we can cancel n minus 1 factorial, n minus 1 factorial, n minus 4 factorial, n minus 4 factorial. Directly, we'll get the value of n as 9. Next question, find r if 5pr is equal to 6pr minus 1. So 5pr can be written as 5 factorial divided by 5 minus r factorial. And this can be written as 6 factorial divided by 6 minus r minus 1 factorial. So which is 6 factorial can be written as 6 into 5 factorial divided by 6 minus of minus 1 is plus. So it is 7 minus r factorial. Now I can cancel 5 factorial on both sides. So here we have 1 divided by 5 minus r factorial. And here we have 6 divided by. So if you go on subtracting 1, then here we will get this as 7 minus r into 6 minus r into 5 minus r factorial. Now we can cancel 5 minus r factorial on both sides. So we have 7 minus r to 6 minus r. 7 minus r, 6 minus r to the left hand side, and here we can write this as 6. And 6 can be written as 3 into 2. Now assume that here we need 7 minus r is equal to 3. So what can be the value of r? So by inspection, if 7 minus r is equal to 3, then r should take the value of 4. So therefore clearly you can see 7 minus r, 6 minus r on the left hand side. 3 can be written as 7 minus 4 into 6 minus 4. So clearly the value of r is 4. So therefore r is equal to 4. So this is by inspection method. Again, we can use 7 minus r into 6 minus r, multiply them, we'll get a quadratic equation. We can also solve using factorization method to get r is equal to 4. So in this session, we have worked out the problems on the formula of NPR. So in the next session, we'll take up the conditions and formation of the permutations. Until then, keep watching, keep learning and keep exploring. Thank you.